Geometry with McCarthy. This is your lesson for Section 2.2, Conditional Statements. Missy McCarthy, Okemos High School Math Instructor. I decided to add in your objectives so you'll know exactly what it is you should walk away with at the end of each lesson. So the objectives for this lesson is to identify, write, and analyze the truth value of conditional statements and write the inverse, converse, and contrapositive of a conditional statement. So we're going to learn what conditional statements are, what the inverse, converse, and contrapositive is, and what the truth value is. So here's what a conditional statement is. You encounter them each day, and they're just statements that are written as, if this is going to happen, then this will happen. So a conditional statement is a statement that can be written in the form, if P, then Q. The hypothesis is the beginning part, the part that follows the word if, and the conclusion is the Q part, or the part that follows the word then. So we call the hypothesis P and the conclusion Q. And sometimes we write it as math symbols as P implies Q, or if P, then Q. We could also write it as a Venn diagram. If we have this larger area here where we're talking about a particular, let's say, rectangles, and then on the inside, our P, let's say a square, we could say if an object is a square, then the object is a rectangle, because squares are part of the rectangle group. Another example we've talked about in class, if two angles are vertical, then the angles are congruent. And we can usually give these statements, or we can give these statements a truth value, whether they're true or false. If they're true, we can prove them. So we can identify the hypothesis and conclusion for these conditional statements. If today, if today is Thanksgiving Day, then today is Thursday. So we've identified the hypothesis and the conclusion. I underlined the hypothesis once and the conclusion twice. This one, a number is a rational number if it is an integer. They're been a little tricky here. The hypothesis is that the number is an integer, and the conclusion then is that it is a rational number. So you can see that the sentences can be written without the words if and then. So we can rewrite them as long as we identify the hypothesis and the conclusion. So here's one here. An obtuse triangle has exactly one obtuse angle. We need to write this as a conditional statement. So I would say if a triangle is obtuse, then it has exactly one obtuse angle. So that would be an example of taking that statement and writing it as a conditional statement, if P, then Q. Here we have an example of a Venn diagram. Again, if the animal is a blue jay, then it belongs to this larger group, which is birds. So we can write this, if an animal is a blue jay, then it is a bird. Okay, just a quick study tip. When you're looking through the section in your book, you can just look for this check it out. And those give you some great additional examples to work on, just so that you feel like you're really prepared with the material. So when you get a chance, see if you can find one of those symbols and try some of those problems in Section 2.2. Okay, so a conditional statement has a truth value. We can say it's true or false. It's only false when the hypothesis is true and the conclusion is false. So if the first part of the sentence is true, and the second part of the sentence is false, then we can say it has an overall truth value of false. So in this one, if the month is August, then the next month is September. So we got to try to find a counterexample to prove that it's false. That's the easiest way to prove it. We have to find a time when the month is August, when that's true, and the next month is September. So the month is August. Okay, that's good. I can live with that. Not that this particular month is August, but if it was August, then the next month is September. And that's also true. I cannot think of an example where the month is August and the next month is not September. So this would have an overall truth value of t. True. If two angles are acute, then they are congruent. So can you think of a time when the two angles are acute but they are not congruent? I can. I would say if angle 1 is 30 degrees, or the measure of angle 1 is 30 degrees, and the measure of angle 2 is 40 degrees, the two angles are acute, so the conditional statement of the hypothesis is true, but these angles are not congruent. So that means this overall conditional statement will have the truth value of false. Okay, in addition to our normal conditional statement, our if P implies Q, we also have several related conditional statements. The first one is the converse. So a statement is formed by exchanging the hypothesis and the conclusion. So we just take the hypothesis, the conclusion, and make it the hypothesis, and take the hypothesis and make the conclusion. So the first one is P implies Q, or if P then Q. The converse would be if Q then P. The inverse is a statement formed by negating the hypothesis and the conclusion. So we're not moving anything around. P is still part of the hypothesis. Q is still part of the conclusion. But this symbol here means if not P, then not Q. So this little symbol here means to negate it. And then a contrapositive is a statement formed by exchanging and negating the hypothesis and conclusion. So a contrapositive is an example of a mixture between the converse and the inverse. So we switch P and Q and we negate them or put the not. So we're going to practice writing some of these. So we are going to write these statements, and then we're going to evaluate the truth value of them based on this science fact that an adult insect has 6 legs. No other animal has 6 legs. So our original if P then Q is right here. So this is our P implies Q. If an animal is an adult insect, so our hypothesis is an animal is an adult insect, then it has 6 legs. So this is our conclusion. It has 6 legs. So we want to take that, if an animal is an adult insect and it has 6 legs, and write the converse. So remember, the converse is Q implies P. So our statement would be, if an animal has 6 legs, then it is an adult insect. And if we try to evaluate that statement for its truth value, based on this science fact, it says adult insects have 6 legs. No other animals have 6 legs. So if an animal has 6 legs, then it has to be an adult insect because of that science fact. So I would say that that has a statement of true. Now let's write the inverse. So the inverse is not P implies not Q. So we're going back to our original and we're just adding the not. If an animal, ooh, how'd that happen? If an animal is not an adult insect, then the animal, then it does not have 6 legs. Now, is that true? If an animal is not an adult insect, so think of an animal that's not an adult insect, then it does not have 6 legs. So that would be our inverse statement. And I would say that that would have to be true. because I can think of an animal that is not an adult insect, and then it's safe to say that it does not have 6 legs then because of the science fact that we have. And so then let's look at the very last one, which would be our contrapositive, which would be not Q implies not P. So we have to take the combination of these two. So it would be if an animal does not have 6 legs, then it is not an adult insect. So if an animal does not have 6 legs, okay, so the animal doesn't have 6 legs, then the animal is not an adult insect. And I would say that that one is true as well. So all of these have a truth value of true.